Hi everyone, this is week 5 tutorial 3 and today our first task is about Gaussian elimination, where we're given 4 linear systems and we have to do the following steps given to us. So the part A is asking us to write down the augmented matrix A given B, and you will take the matrix A and B from the linear systems given to you. So here in the first linear system you have 2x1 minus 1x2 plus 3x3 and plus 2x4. So we'll take these elements here as our elements of the matrix A, which is 2 minus 1 3 2. So this is row 1, and for the part B it is 4.5, and so on. We'll write down the matrix for all of these linear systems. And also notice that in the third equation it is minus 2x1 plus 4x2 and minus 6x3, but there is no x4 given, which means x4, the value of the element in the matrix, will be 0. Okay, then let's start writing the matrix A given B now, the augmented matrix. So our part A is about writing the augmented matrix. So we have here from the first row 2 minus 1 3 2, and then given B, which was 4.5. And then for the second linear system we had the values 4 minus 1 4 5 12.5, and then we have minus 2 4 minus 6 0 and 3, and then we have 1 minus 0.5 minus 1.5, and this is again 0 because there was no x4 value given to us. And then we have here 2.25. Okay, so we're done with the first part. Now the second question is solve the system of linear equations using naive Gaussian elimination and find the determinant. So let's start working on part B now. To solve the augmented matrix using Gaussian elimination, so let me write down or take the matrix from here again. Okay, now what we're supposed to do is, let's say we will draw a line below the diagonal, and all the elements that's below this diagonal, that is these elements here, should all be turned into zeros. Okay, so we'll start working on that now. So the first thing we need to do for us is we need to make our row 1 freezed. So we freeze the first row, we don't change anything in it, and then in the first column we look at the elements below the first element of the freezed row. So we look at these elements here and we are supposed to make them to zeros. But then these are our elimination factors. This is our elimination factor L21. This is our elimination factor L31, and this is our elimination factor L41. So we're supposed to now find out the elimination factors. So let's find out what is L21. L21 is A21 divided by A11. So it's all the time we'll take these elements here, A21, A31 and A41, and we'll divide it by the element of this column at the top, this element here. So that's A11, right? So we'll always divide it by A11. So here A21 is 4 divided by 2, so we'll get the answer of L21 as 2. And we will use the L21 now to write an operation for the row 2. So the L21 was found for the row 2, so this will be used for an operation for row 2. So what will be the operation? It will be row 2 minus L21, which is 2 times the freezed row, which is row 1. Okay, so that's the operation we will carry out for row 2. Now let's find out the value for L31. L31 will be A31 divided by A11. So A31 is minus 2 and A11 is 2. That's minus 1. So the row operation for the third row will be row 3 minus L31, which is minus 1, times the freezed row, which is row 1. And then we'll find out now the value for L41. So L41 is equal to A41 divided by A11. So A41 is 1 divided by A11 is 2, and that gives us the value 0.5. So the row operation that we'll carry out for the fourth row will be row 4 minus L41, which is 0.5 times row 1. Okay, now let's carry out these operations here that we have just arrived at and find out our next matrix. So once you're done with these operations, you're done with the step 1 of the forward elimination. So here let's work on these row operation now, the first one. So and better before that, let me write the row that we freezed. So we have 2 minus 1, 3, 2 and 4.5. So we don't change anything in the freezed row. And then now we have row 2, which is 4 minus 2 times row 1, so 2 times 2, so 4 minus 4 is 0. And then we have minus 1 here. So row 2 minus 1 minus 2 times minus 1, which is plus you have for this one here, you have minus 1 minus 2 times minus 1. So that will be minus 1 minus minus 2, which is minus 1 plus 2, which is equal to 1, right? So here we'll have a 1. And then if we do the work for 4, so 4 minus 2 times 3 is 6, 4 minus 6 is minus 2, and then 5 minus 4 is 1, and here we have 12.5 minus 2 times 4.5, that's 3.5. So I'll write down the values that we'll get for the next ones. Okay, first let's calculate this one at least. So we have row 3, which is minus 2 minus 1 times row 1, which is 2. So you have minus 2 plus 2, which is equal to 0 again. So you can also write this as like row 3, minus into minus is plus, row 1, right? So for easy looking, you can write this as row 3 plus row 1. So you will always have here then 4 plus minus 1, which is 3, and then you have here minus 6 plus 3, which is minus 3, and then you have 0 plus 2, which is 2, and then you will have here 3 plus 4.5, which is 7.5. And now the last one, we have row 4 minus 0.5 times row 1. So 1 minus 0.5 times 2, which is again 0. So we successfully finished making the first column all the elements 0 after the first element. And then for these values here, we have 0, minus 3, minus 1, and here we have 0. So now we are done with the step 2, and we are done with all the operations here. So I'll erase this part. Okay, so that's now we'll work on our next step. So we'll work on making, first was freeze. So what we already finished working with, you can say, is we are done working with the first row and the first column, so we don't change any more things in those two. So now we work only with the matrix that's inside these here. So we'll work with the smaller matrix here now, and from here now again we'll freeze the first row. The first row, we freeze it again, we don't make any changes to it, and we'll work on these elements below the first element of the first column. So this is our L3, 2, and this is L4, 2. So we'll find out L3, 2 and L4, 2. Let's find it out this side here. So L3, 2 is equal to A3, 2 divided by, as you know, we always divide it by that the freezed column's first element, sorry, the freezed row's first element here. So that is A2, 2. So we have here A3, 2 is 3 divided by 1, which is equal to 3, and then L4, 2 is equal to A4, 2 divided by A2, 2, which is 0 divided by 1, which is equal to 0. So now let's write our row operations. So for this row here, now our operation will be row 3 minus L3, 2, which is 3 times the freezed row now. So the freezed row now is row 2. And then we go to this row 4, and the operation will be row 4 minus L4, 2, which is 0 times the freezed row, which is row 2. So now once we can do these two operations, we'll reach our step 3 matrix. So let's try to first write it. Okay, I'll copy this to the other page so you can see it easy. Okay, so let's carry out the row operations now. So first let me write down the fixed elements: 3, 2, 4.5, and here the fixed elements are 1, minus 2, 1, and 3.5. So this doesn't change anymore. Now let's work with the row operations. So you have 3 minus 3 times 1, which is 3 minus 3, which is equal to 0. And then you have minus 3 times minus 2, and that is 3. Then here we have 2 minus 3 times 2, which is 2 minus okay, so it's 2 minus 3 times 1, so that's minus 1. And then here we'll have 0 minus 0 times root 2, so we don't have to do anything which is 0 times root 2, so you can just say 0 minus 0, which is 0. And then we have minus 3 minus 0, so there also we have minus 3 again. And then we have here minus 1 minus 0, so it's again minus 1. And here I've got to write it down, so we have here now minus 3 and 0. So now we're done with the step 2, once we're done with these row operations here. And what we are left with is, okay, first let me draw again where we are done with freezing, right? So we are done with now this row here and till here. So once we're done till then we only have this inner matrix to work with now. And from this inner matrix again, we freeze the first row. Once we're done freezing it, the elements below the first column of the first element, we take those elements and we find out the elimination factors of them. So this one here, the elimination factor is named as L43. So let's find out L43 now. L43 is A43 divided by the element in the first element in the freezed row. So we have that as A33. So A43 is minus 3 divided by 3, which is equal to minus 1. So the row operation for this row here now will be row 4 minus elimination factor is minus 1 times the freeze row, which is row 3. For simplicity, you can write this as row 4 minus into minus is plus row 3. So now let's start working to get our next matrix. But before that, let me write all the elements which are already fixed. They don't change anymore. So here we have minus 3, minus 1, 3, 2, and 4.5. Then here we have these also fixed, 1 minus 2, 1, 3.5. And then we have here 0, 0 fixed. And here now we fixed a new line or new row, you can say 3 minus 1 and minus 3. And then we work with the last row. So here now we have row 4, which is minus 3 plus row 3, which is 3, minus 3 plus 3 is 0. And then we have minus 1 plus minus 1, which is minus 2. And here we have 0 plus minus 3, which is minus 3. Okay, so now if you look below the diagonal, elements, all the elements here are zeros, which means that this is already in the form of upper triangular. So this is already the upper triangular matrix. So therefore we have finished coming to the end of the Gaussian elimination, and now we can work on getting the x values, the solution vector for us. So maybe I'll copy this to the next page so we can work on the solution vector. So let's start from the last row here, because this is having the maximum zeros. So we have minus 2 times x4 is equal to minus 3. And then we can say x4 is equal to minus 3 divided by minus 2, which is 3 divided by 2, which is 1.5. And then for the second last row we'll have the equation, which is 3x3 minus x4 is equal to minus 3. So here we have 3, you can say x3 minus or equal to minus 3 plus x4, which is 1.5, and then the whole thing will be divided by 3. So x3 will be equal to minus 0.5, and so on if you solve for the next ones, which is 1x2 minus 2x3 plus 1 is equal to 3.5. So you'll get from these x2, which is equal to 1. So you have to replace the values of x3 and x4 that we already got here. So this is x4. Okay, so now we have already the value for x4 here, x3, x2, and the last equation is 2x1 minus x2 plus 3x3 plus 2x4 is equal to 4.5. And if you solve that with replacing all the values for the x's that we received until now, you will get x1 is equal to 2. So you can say that the solution for us, the solution vector x is equal to 2, 1, minus 0.5 and 1.5. Okay, so we are done with that one here. Now let's go to the question again. So here it says solve the linear system of linear equation using named Gaussian elimination. We're done with that. And now it says find the determinant. So we need to find out the determinant. So the determinant of A is actually equal to the determinant of U, the upper triangular matrix. And as you know that this matrix of us is now in the upper triangular form, so this is the upper triangular matrix for us now. So we can just find out the determinant of this matrix, which will be the multiplication of all the diagonal elements. So we take all the elements in the diagonal of this matrix, that is these elements here, and we multiply them. So that determinant of U is equal to 2 times 1 times 3 times minus 2, and that's equal to minus 12. So that's the determinant of A. Now let's go to the next question. The next question is saying check your solution by substituting it in the original linear system. So let's do that now. Let's take one of the linear systems that was given to us, which was minus 2x1 plus 4x2 minus 6x3 is equal to 3. So this is one of our linear systems that was given to us, right? I took this one here, minus 2x1 plus 4x2 minus 6x3 is equal to 3. So we'll replace our values of the solution vector x here, and we'll see if we reach the value 3. So if we look at our values of the solution vector here again, let me paste it here. So we have minus 2 times x1, which is 2, plus 4 times x2, which is 1, minus 6 times x3, which is minus 0.5, and this should be equal to 3. So if you solve this, you'll see this is 3, which is equal to 3, and that's true. So the rest of the linear systems can be done by all of you. You can do and check them that they're actually equal to the value. That's it for this question here. Thank you.